Okay, hello everyone. This is a new setup for me with a new computer, so hopefully everything goes smoothly. This is our tutorial video for Project 3, SillyQL. And the first and most important thing I want to say is make sure that you read the tips and tricks and pitfalls section of the spec. There's lots of useful information in there, like easy ways to read and write a Boolean, how to use the field object correctly, some of which is going to be repeated in the video. Lots of useful stuff in there. Next up, I want to tell you something not to do. Don't use string streams. And the reason is you end up processing the input 3 times. You get a line into a string, then you turn the string into a string stream, and then you use greater than, the stream extraction operator to pull things out of the string stream. Just go back to greater than, and read them from CN. For most of this project, you're going to be using greater than, because our language in SillyQL is very well formed. What I mean by that is that once you read one thing, you know what's coming next. So the only times you should use getLine is basically for a comment. Anytime there's a comment, use a getLine, get rid of the whole thing. Anytime you encounter an error in a command, like we say to create a table that already exists, you get rid of the rest of the stuff on that line and ignore it and print out an error message. And a working project shouldn't need more than that. One getLine for a comment, one getLine for every error you encounter, and that should be it. Something that you should be doing is object-oriented programming. Because we're going to be making tables, because we're simulating what's happening in a database, and so you should have a table object, a table class, and make member functions of that class for the commands, most of the commands anyway. And when you start processing the command outside of the class, then once you have enough information to proceed, like, hey, I've got a table name, then start calling member functions to do the rest of the work. Now, most of the commands, and I'm going to assume you've read at least some of the spec here, we'll make it obvious. So most of the commands are going to need a member function. The ones that don't is a comment, because it doesn't do anything. The quit command, because it doesn't do anything with a table, it just quits the program. And it turns out the remove function doesn't really need a member function. It just needs some higher level code to get rid of the table. Now, the other thing that's important about this project is it is meant to be built in pieces. Don't feel like you have to understand everything about indices and how indices affect other commands and how join works in order to start working. You don't have to. In fact, even if you write code without even thinking or worrying about indices, later on you're going to say, oh, now I've got an index, I've got to do the code for that, and then you're going to say, oh my gosh, I've got to go back and rewrite everything. No, if you've done a good job, you're not going to be throwing away original code. What you're going to be doing is adding a little bit of code to say, hey, if there's an index and blah, 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 then new stuff. And possibly old code goes in an else clause, or maybe it's just new code that gets added. So for the most part, with one exception, I'm going to warn you about that a little later, except for that one command, which I'll warn you about ahead of time, you shouldn't have to throw any code away when you get to indices. You're going to go and you're going to put that existing code inside of an if or inside of an else, and then you're going to have other ways to do things. Okay, so as you're writing this project, if you don't have a command written yet, you're like, oh, that join, I don't understand that. That's okay. But at the very least, make a condition so that you know you've seen a join command, and do a get line to throw the rest of that line away, because otherwise you might process it as if it was a command. So for example, if you just read the word join and you go back through and read another command, maybe it was join cars marketplace, blah, blah, blah. Well, you see, hey, I read cars marketplace as a command. Ooh, look, it starts with a capital C. Must be a create command. And then everything goes sideways after that. So if you don't have a command done, that's okay. Just recognize that this is the join command, do a get line, call it done for now. So starting point for this program, obviously, the command line. There's only one command line option you really have to worry about, which is quiet mode. Help you can do, it's not a big deal. The autograder never tests help. But I would still use get op long is the easiest way to do things. Get off long, quit and help, long version, short version, or sorry, quiet mode and help, long version, short version, and then start reading input. And I want to talk about how to read input correctly because it's really important in this project, and we're going to want to use something we haven't done before. I'm going to switch my inputs up over here. Should be ready to go on my iPad. Okay, so I've got some code written up already, which is basically the starting point for the program. I'm going to need, looks like I got ahead of myself here. I forgot one thing. I'm going to need a string variable for the command. Okay, so I got a string variable for the command. I created that variable. Then I start my loop, and the do while loop starts here and ends here. The do while loop is a post-test loop. For and while are pre-test loops. They test the condition before they do anything. But in this project, I want to stop on a quit command. But if I haven't read a command yet, I don't know what the command is. So we have to read at least one command so the do while loop is the right structure. So we say, do this stuff, and then we test the condition. So what are we going to do? Now this part here is not necessary for a perfectly working program, but it's in the tips section. It's an important thing to put in there while you're working on it so that you don't get weird infinite loops of garbage output. Hello, Spencer. Now you're going to make me show cat? Okay, we have to show cat. So Spencer wanted to help. Come here, buddy. Oh, no. Come here. He doesn't like to be held much, but this is Spencer. He had to come and say hi because, of course, I'm recording a video. So here, why don't you sit on your own chair next to me? Okay, there we go. So if you see me doing odd things with my hand, it's because I've got to pet a cat to keep him happy. Okay, so when we start reading here, this is in the tips and tricks and pitfalls section, this if statement here. This is to make sure if things go really sideways and your program like thinks it's in the middle of a create command when it's not, and you start trying to read integers when there's strings, we don't want an infinite loop producing lots and lots of garbage that's hard for you to interpret or filling up the hard drive on the autograder. So add this if statement in. It's in the tips and tricks section. You can just copy and paste it. Okay, so then after that, we print a prompt with cout, %space, and then we read a command. This program is intended to simulate something that you would actually use, like typing commands on the keyboard, not something that we would run with input files, but for the purpose of testing it, most of the time you're going to redirect input. But a real SQL database tends to get used by people typing commands. So that's what it's intended for, is prompt them with the %space, then read a command. And then this is where we go and start figuring out, whoops, I got to get used to my new iPad here with the change of eraser and stuff. Okay. And then we start figuring out which command it is. And there's somewhere in the spec, I don't remember exactly where, that tells you that you can look at just the first letter of each command. Like if it starts with a number sign, it's a comment. If it starts with a capital C, it's create, etc. So you can depend on that. So you really only have to check the first letter of everything. And then you start processing all those commands. And then we get to the point where the while statement here at the end, which for some reason my iPad wants to highlight, the end of the do while loop is saying, keep doing this stuff while the command is not the word quit. And again, you could just check the first letter here if you wanted to. Okay, so that's the basic loop to get things started. So then let's go back and switch inputs again. And then, okay, so let's talk about, okay, so when you start with commands, what's a good order to start processing commands in? Well, quit command. The quit command is almost done on the screen I just showed you. The only thing is, in the start figuring out what command it is, you're going to have a trailing else for an unrecognized command. Like if something starts with a capital Z, we don't know what that is. So there is an error for an unrecognized command. So to make sure you don't get an unrecognized command for quit, you need, like, if the command started with Q, well, don't do anything, but it's not an error. Okay, so quit is almost done. The next command I would say to do is comment, because it's pretty easy. When you see a number sign, you do a get line, throw that stuff away, we'd ignore it, come back through that do while loop, check if cin failed, print another prompt, go get another command. Okay, so that takes care of the really easy ones, quit and comment. After that, to be able to see that anything is actually working, you need the create command. So that way we can set up all of the other commands that would happen with tables. So you've got to be able to create a table before you can put stuff in it, print stuff from it, etc. So get create working. Now after that, you might want to jump to print, but resist the urge. Do remove first, because remove it's not exciting, but it's easy. It's pretty short. And this brings us to a point about the create and tables is this program is intended to keep track of potentially lots of tables. And so you need to have, at the high level, you need to have an easy way to go from a table name to a table object, which I told you should create a table class and a table object. Sounds like unordered map, a way to go from a string to the data that's associated with it. So the remove isn't going to be too bad. You're going to check and see, like, oh, if this table doesn't exist, remove is an error. But if it does exist, tell the unordered map, get rid of this thing. Okay, so remove, not too exciting, but easy to code up and easy to test. After that, the next two biggies are insert and print all, because that's where you can really start seeing that things are working. So insert puts data into the table, print all to see that the insert worked. Okay, and that's not terrible to do, either of those. Insert will be a little bit of work, and we're going to go through these in more detail later. But insert is going to be a bit of work. Print all, not too bad. And after those things work, then you can start worrying about the more complicated stuff, which is delete, which gets rid of rows, print where, which only prints some of the rows, not all of them, generating an index, and join. That's all the complicated stuff. Okay, so I already mentioned the high-level stuff. Okay. Now, when we've done things before, like with a vector, everything had an index. The index was the key. But now, if I've got 20 tables, I want to get to a table really fast. That's where the unordered map comes in, to get to that table fast and not have to look it up and linearly search it. We're past the linearly searching stage. We want to avoid that whenever we can. So like I said, we want to have some sort of unordered map that maps from strings, table names, to big table objects. So big table objects, what goes in the table? Well, the window here is actually pretty useful, the cars marketplace. So the table name, it turns out, yeah, the table name is going to be in the unordered map, but I'll give you a hint. I found it was a lot easier if there was a little bit of redundancy in the data and every table knows its own name. Because when you get to error messages, you have to say, like, I was in the middle of a print all command and this column doesn't exist in cars marketplace. So for that member function to be able to print its own name, the name of the table should be a member variable. So that's a little redundant, but going to save you some grief later on. Okay, so then another way to think about it is the stuff that has to go in a table object is basically everything you see in the cars marketplace here. You need the gray stuff, the table name. You need the blue stuff, which is the column names. Those come from the create command. The column types, which also come from the create command. They're visible here, but we can kind of infer from looking at the data that vendor contains strings, model contains strings, miles looks a lot like integers, and prices contain doubles. So the table should know its own name, what the column names are, what the column types are, and then that's what you need to do to get the create command working. Later on, you're going to add the stuff with a white background, the data that comes from the insert command. So that stuff all has to be in the table class. And how you store that stuff is not as critical because it tends to be the case that databases tend to have a lot more rows than they do columns. So whether you have like a vector of column names and a vector of column types, or you're like, I need an unordered map in here to make things faster, it's not a huge deal. I've written it both ways, like with two vectors. I've written with like a vector and an unordered map and stuff like that. Not a huge deal there. So do it whichever way seems easiest to you. Okay, so the important thing is you can't, you've got to make sure you have a way to know which column something is. Like I have to know that model is column 1, because when later on I get to like printing stuff and someone says like print the model column, I've got to know that model is index 1 of each row of the white stuff. So you've got to have a way to know the column names, know the column types, and be able to know which column name goes with which column number. Okay, so when you do the create, you remember all that stuff, and you create the table object, and we'll talk a little bit more about that later. And the stuff that comes from the insert command really should be a lot like what it looks. So we're getting into more important stuff here. So it really should be a 2D vector. You don't want to start saying, oh, well, each column should be a separate data structure. That's going to produce a lot of grief for you when you get to the delete command. So let's not do that. So we really do want a 2D vector to represent that, the white background stuff there. Now, the data types here, so it looks like a 2D vector should be a 2D vector, but a 2D vector of what? Well, it couldn't be a 2D vector of doubles because, you know, the vendor names are strings. It can't be a 2D vector of strings because the miles have to be as integers. And it's important to store them as what they are because later on, like if you say, oh, I don't want to do what they said, I'm just going to make a 2D vector of strings and call it done. Later on, when you get to indices and binary indices, things are going to come out in the wrong order because the string 1, 2 is less than the string containing 3. But really, if it was integers, 3 would come before 12. So we can't make a 2D vector of strings. We can't make a 2D vector of ints. This is where starter files that we gave you came in. So we gave you a bunch of header file, a bunch of starter files with like inputs and outputs, but there's also field.h and field.cpp. And that's, there's two important things in there. I wouldn't look too closely. There's some really ugly stuff in there. But if you look in field.h up to about line 20, that's enough. So what you know by line 20 is there's two important types going to be defined in there. One of them is called field, and one of them is named field.h and field.cpp. So there's the field class, and there's the column type. So column type is just an enumerated type. You've seen those before. You should use that for the create command and to remember what the type of each column is. You have to read in the type of the column as a string, like the word double, but don't store it as a double because that's big and it's slow to test. So read it in as a string, remember it as a column type, that enumerated type. Now, the field is what should be in the 2D vector that's the result of the insert command. So remember, the column type is just an enumerated type. It can tell you the type that a column is, but it doesn't actually hold anything else. It just remembers like, hey, the vendor column is strings, the model column is strings, the miles column is integers, the price column is doubles. Now, the field is actually what's going to contain the actual values. And field is called a variant type. It is a type that can hold multiple other types, and it's done as efficiently as possible, and there's cool stuff in there. But what it does is the field type can be constructed from any one of the 4 column types, which are string, double, int, which we've seen in this table, and bool, which isn't in this table, but is the other column type is Boolean. So once you have a field object that holds one of those types, it will then behave as if it was one of those types. And what that means is if you've got a field containing a string, you can compare it to a string. Or you can compare it to another field which contains a string. You cannot contain a field with a string to an integer. Bad things happen. In the debug executable, you'll get assertion failures. They're like, hey, you're trying to compare a field that contains a string to something else, and that's not allowed. So do run the debug or valgrind executable. The release executable, like /silly, that one won't give you errors if you mix types inappropriately. But the debug and valgrind executables will warn you about that. So the other things you can do with them is you can output them. So you can output them, like if it contains a string, it'll output like a string. If it contains a double, it'll output like a double. The one thing you can't do, so like I said, it behaves like a variable of that type, except you can't change the value. Once you make a field that contains Corvette, that field contains Corvette forever. There's no place in this project where you can change values, which makes it not quite as cool as real SQL, but a lot easier to code. So there's other things you can't do with fields. One thing you cannot do with a field is you cannot default construct it. And the reason is a field is designed to hold one of those 4 types. So it can't hold nothing. So there is no default constructor for the field object. So, and another thing it can't do is it cannot be involved in an assignment operator. You can't change it, and you can't set something else equal to it, because that would be too much copying. So if you get places where you're writing your code and you try to compile it and you get compiler errors that tells you like you're trying to do an assignment operator and it doesn't exist, that's why you're not allowed to copy field objects. Now I shouldn't say that. You're not allowed to assign them. You can copy them, like you can pass one by value if you want to. Really, you should pass it by reference or constref. So you can pass a field by constref, you can pass it by value, but you can't equals it. Like it can't participate in an equal sign. Now, one thing that means that's really important actually for the create command is you can't say, hey, when I write the create command, I forget that member function stuff. I'm just going to create this table temp, and I'm going to put all the table name and the column names and the column types inside a temp, and then I'm going to take temp and I'm going to copy it into my unordered map. It doesn't compile. Because if you're copying a table object, you're copying a 2VD vector of fields, which means you're copying fields, and fields can't be assigned like that. So that will not compile. So instead what you should be doing, remember I said member functions. You should be doing things like, hey, if they're trying to create a table that already exists, that's an error. But otherwise, I can be like, square brackets that table name, call the create member function. Because as soon as you square brackets that table name, bam, the table exists. You call the create member function, and create does everything else. Like the stuff outside of the member function should read the word create, it should read the table name, figure out if it's a valid create or not, because it already exists, it's bad. But otherwise, square brackets call the member function does everything else. Other thing it means is there's going to be something when we get to insert. So I'll talk about it. There's something else we can't do when we get to insert. I'll talk about that. So actually, yeah, we're kind of at this point. Let's talk about insert. So when you do insert, you have to do it efficiently. Of course, it's 281, right? So you can resize the number of rows. Like, like Cars Marketplace here right now, it's got 1, 2, 3, 4, 5, 6. It's got 7 rows worth of data. Let's say I said insert 100 more rows. Oh, let's do 102. No, sorry, I'm off on my numbers. Yeah, let's do 100. Let's do like 130 more rows. So if I say, hey, insert 130 rows, if I just let it grow organically, it would grow up to like 137, but not really. It would have 137, but behind the scenes, there'd actually be 256 rows, and almost half of them would be wasted. And if I let the columns grow organically, with 4, not too bad. But what if there were 5? It would grow by doubling, and I would be using 5 out of 8 columns in each row, and I'd be using 137 of the 256 rows. I'd be using like 1/4 of the data. So we do want to resize the number of rows. So I'd say like, hey, I've got 7 now. They want to insert 130. Let's resize it to 137. And then let's start at row 7 and start inserting some new data. Now, when you get to row 7, you can't resize the row. Because if you were to resize the row, you would have to default construct every column, and that won't compile. So you can reserve the number of columns. So you resize the number of rows, reserve the number of columns in each row that you have to put data in, and then you do the reading the data and putting it in there. Now, as we're working with the insert command, what we're going to have to do is we're going to have to say, basically, for every one of those new rows, reserve the right number of columns. Then for every column that is going to exist, because the insert command has to have data for every column that's going to exist, I've got to read something and put it in the 2D vector in the row. So I'm going to have a for loop for the rows, do a reserve, for loop for the columns. Now when I get to the columns, I've got to do a 4-way split, because the column type could be one of 4 things. You're like, well, can't I just read that double as a string? Yes, you could, but that's going to mess stuff up. So do a 4-way split. If this column is supposed to contain a double, create a double variable, read cin into a double variable, and then add stuff to the row. And add stuff, I'll get to that in just a second. Now this 4-way split is important because it's going to come back again in the delete command, because there's a where clause in the delete command, and it's going to come back again in the print where command, because there's multiple types there. And it's going to come back again in the join command, because there's multiple types there. Now that we've got something like a double, it's time to learn something important that you may not know already. So we need to learn the difference between pushback and emplaceback. So what we've been using up until now is pushback. And what pushback means is basically, let's say I've got a vector of type int, and I have an int, I use pushback. I've got an int, put the int in the vector. Now, suppose the vector doesn't have that type. Suppose I've got a vector of, say, fields. but I just read an integer and I want to put that integer inside of there, but I want to turn it into a field. The wrong way to do it is to create a temporary field object containing the double, then push back the double. That's the inefficient way of doing it, and it's the way that doesn't show employers that you really know your stuff. So the way to show them that you really know your stuff is like you say, hey, I've got a double, but this is not a vector of doubles, it's a vector of fields. But there's a constructor that can take a double and produce a field. That's where you use emplaceback. So you emplace back the double, and basically emplaceback says, I've got this thing, hand the thing off to the constructor at the exact right spot and construct it where it belongs. And it's really super efficient. So we want to emplace back what we read, not push back. And we can't push back in a double because it doesn't contain doubles. We don't want to create a temporary variable. We just want to emplace back the double. A constructor that converts from a double to a field runs automatically at the right place. Okay, so we do that for every row, for every column. I do a four-way split on the column type, read that type, emplace back, go back through. Another column, check the column type, read the stuff, and then when I move to a new row, reserve the right number of columns, loop through the columns within that row, read it, four-way split, etc. Okay, so now we've got insert done. Now is the time to print all, because then we can see that the insert actually happened. Now, technically, you could do this with your debugger. If you're really excited and you want to know if that insert worked, open up your debugger, open up your unordered map, open up the table object, open up the 2D vector of data, whatever you call it, open up the stuff in there, and it's going to be a little bit hard to read because there's these variant types have basically every field object has 4 member variables, but only one of them will make sense. So it might be a little bit hard to read in there, but it's there. Okay, so print all. Let's talk about print all. So when we do a print command, let's just forget print all, just a print command itself. When we print the print command, it's like print from table name, okay? So I read print, I read a junk word, I read the table name, make sure it exists. If it doesn't, I print an error. And now here's the place where we want to start doing some member functions and helpers, etc. So you're not going to need all of this to begin with, but you're going to need, when we get to that, actually, let me just go through the spec. Let's get to the print command so we can see the syntax here. Okay, print. Okay, so we say print from table name. Okay, so I read the table name and then I call the member function. Then the member function can read n, the number of columns. N is the number of columns to print. So when I read a 3 here, I know I can loop 3 times and read 3 column names. Make sure all of those column names exist. If any of those don't exist, there's an error for that. But if that succeeds, then I read the next part, which is either going to be the word where or the word all. And now here's a great place for a helper function. Make a helper function for print all, make a helper function for print where, code it up later. All right, so then we want to do a print all command. So now for print all, they want, what all means is it refers to the rows. Wait, where'd my mouse go? Okay, so the column names here, these are what in each row they want to print. But it looks like I've got a little bit of a problem with the width of my screen and the width of the share. Okay, yep. So I've got so these are the names of the columns I want to print within each row, but the all means I want to print all of the rows. So if someone said, like going back to our cars marketplace, if someone said print 2 things, vendor and or model and price. If someone said print from cars marketplace 2 things, model, price, all. That would mean we want to print every single row as the all, and we want to print the model and the price for each row that we see. So then we would start a loop. Outer loop is for every row of the table. Inner loop is for whatever columns they want to print out the data in those columns. Oops, there we go. Multiple windows open here, and I actually have multiple monitors to keep track of my recording software and everything else. Let's make sure the recording's okay. It's still recording. Good. Okay, so print all is going to have those loops. Make sure you get a \n after every row, but not in the middle of it. Also, after every column, print a blank space. Even after the last column, print a blank space. So if I said like, it would print like Corvette space, 25965.00 space, and then it would go to the next line. So you can have a space after the last one. You don't have to code that up special. So then with the print all, now we can see that the create worked, we can see the insert worked, we can see print all is working. Try it with, multiple different commands of what if I print this column and then that one? What about that one followed by that one? Make sure everything comes out in the right order. Do it with tables that exist, with tables that don't exist. Do it with columns that exist, columns that don't exist. Test all those things before you move on to the next. Okay, so then after we got those done, also make sure to test it. I mentioned this earlier, but I didn't say it out loud. Test it with multiple inserts. I've seen people's code work perfectly fine with one insert, but as soon as they do 2 inserts, stuff starts breaking. So make sure you test it with more than one insert. Do like create, print all, better print nothing because there's no rows, right? Then do an insert, then a print all, then do another insert and another print all to make sure that that second insert worked properly. It didn't overwrite the first one, didn't produce garbage data. Make sure that works. Okay, who's up next after that? I would say delete command. Now the delete command, again, might want to have some maybe a helper function. And the reason is we've got to do a 4-way split. So if we look at, let's bring over our spec here. Let's go to the delete command. And I wish I'd realized the width thing. Let me see. If I change, okay, just a second. Let me try changing. Oh, now that's a little too narrow. Okay, I'm trying to get the width to the point where it doesn't wrap. Okay, that seems okay. So now, all right, here we go. Wait, I went too far. Okay, where's my delete command? Okay, there we go. So here's my delete command. So delete command, you say delete from table name, where column name, some operation, and then a value. So you read the delete from table name, make sure it exists. If it does, start calling the member function. Member function reads the junk word where, read a column name, read an operation, and then you have to do a 4-way split because depending on the column name and the column type, how you read this value is going to be different. So the operation is always just a single character, but the value is different. So we need a 4-way split here so that we can read the value. So like if it was a double, I'd read a double, and then I call the helper. Now, and the reason I want to have a helper function is that helper is going to have to do less than, greater than, and equal to. And what I don't want to do is I don't want to code up delete 12 times, right? You could code up delete once and be like, oh, I'll just copy this 12 times, change this type to that type, change this equals to that greater than. You could, but don't do that. Resist the urge to write delete 12 times. So instead, in the starter delete function, we do a 4-way split on the type. We read what we need, like an int or a double or a string or a bool, and then we call the helper function, like the delete helper. All right. So, like for example, let's go back to the example of the cars marketplace. If someone says like delete from cars marketplace where price is greater than 50,000, like we just know they're not selling, let's get rid of them. All right. So that's what I did in the command to the program. So I read the delete from, table name, it exists, call the member function, read the word where is junk, read the column name, which is price, and then I read the greater than, it's always a character, and then I got to do a four-way split, read up that double. Now I want to call my delete helper, but what do I give it? Do I give it a double? No, if I give it a double, I'd have to write it 4 times. You could give it a templated type. We don't need to. Instead, simpler way is if you read a double, just create a temporary field variable containing that double. You're like field, temp field of temp double. Done. You got a temporary field object. Now you can pass that field object to the helper. The helper doesn't have to be templated. It just says, hey, I accept a field object. Psst, by reference. Don't pass them by value. Okay, so the helper accepts the field object, and then the helper can then do this 3-way split on type to figure out, hey, I do less than this way, greater than that way, equal the other way. So in the delete helper, I'm going to have to be passed the field object, and I'm going to have to be passed the comparison. And I got to have like the column name or something way to know which column I'm supposed to be working on, because I got to know the type has already been read, but I'm going to have to know the column number later on. Okay, now when we do the actual work of getting rid of those rows, you want to use the STL. So there's an STL algorithm, and it's one of the ones that's listed in Canvas files, resources, algolist.pdf. It's one of the ones in there. So think about what you're trying to do. You're trying to get rid of things from a container, and you don't want to get rid of all of them. You want to get rid of some of them based on some conditions. So look for the one that does it. And what that algorithm is going to have to be given is basically like your 2D vector begin, your 2D vector end, and a functor to help it decide which rows need deleting. And basically you need a functor that's going to return true for the rows that should be deleted. Now, the reason you want to do it using the STL instead of coding yourself is if you code this yourself, it's very easy to end up with delete rows being O of n squared. And the STL algorithm is going to do it in O of n time. So we want the O of n time. So the functors, this is where it's going to be a little tricky. This is going to be like the trickiest functor you ever wrote. So it is not a comparator. So let's think about what's going to happen, right? We give this STL algorithm the beginning and end of our 2D vector. It has to loop through that container, and everything it sees, it's going to show it to the functor and say, hey, functor, should we get rid of this? Yes or no? True or false? So the functor has to be accepting something from iterating over the entire table. Now let's do a simple example. If I had a vector of like strings and I wanted to get rid of like everybody named Bob, right? The vector of strings, I would loop through the vector of strings, or I wouldn't loop. The STL algorithm would loop through the vector of strings, and it would be like, here's Tom. Hey, functor, should we get rid of Tom? Okay, here's Mary. Functor, should we get rid of Mary? Oh, here's a Bob. Functor, should we get rid of Bob? So the STL algorithm is going to loop through the strings. It's going to hand a string off to the functor. If it was a vector of integers, it would loop through the vector of integers, and it would show an integer to the functor. Well, you've got a vector of stuff. It's going to loop through your vector of stuff, and it's going to pass a stuff to the functor. Well, what is your vector? It's a vector of vectors. So what the functor has to accept is actually an entire row, an entire vector of field objects. Oh boy, you better pass that by reference, const reference, right? So the functor has to look at a row and go, hey, this is a row, it's got this stuff like Chevrolet, Corvette, 67,000, 25965.00. Should I delete it? Well, wait a minute. Now, the functor already knows what type of functor it is, right? Like if you created a get rid of equal rows functor, it can do equals. But what it doesn't know is what column should I look at and what value should I be comparing it to? The STL algorithm cannot give those to the functor. The functor has to know them. The functor needs some member variables. Inside of the functor, it's got to know what value to compare to and what column number to compare to. It's got to know, oh, you should be comparing column 3 to this 50,000 because that's who we want to get rid of. We said we're going to get rid of any row that has a price greater than 50,000. So it's got to know column 3. It's got to know then when it looks inside of that vector of fields at column 3, it's got to have something to compare it to. Wait, what should I compare it to? A field object. A field object that better contain a double because I'm comparing it to a column that contains doubles. Okay, so you're going to write one functor, like write one for equal or greater than or less than, get it compiling, get it working, and then once you got it working, the other two functors are just going to be copy the functor, change the name, change the comparison, write some new code to create the new functor, off you go. So the first one is going to be the hardest. So it's going to have some member variables, it's going to have a constructor, and it's going to have an overloaded operator parentheses that accepts a row. Now, one other thing you have to be careful of. Once you find the STL algorithm that gets rid of stuff, the name is a little misleading because it doesn't actually get rid of them, it rearranges them. It rearranges it so that the rows we want to keep come first, and the rows after that are who knows what, they're not well defined. So for example, in the cars marketplace here, if we got rid of the ones over 50,000, we would be left with the first Corvette, the first Malibu, the second Malibu, and the third Malibu. That's all that we'd have left. We'd get rid of the second Corvette, we'd get rid of the Mustang, and we'd get rid of that Fusion, which I just realized has a weirdly high price, but oh well, too bad. Video's half done. Okay, so it would rearrange it so that we had like Corvette, Malibu, 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 and who knows what's in the other three, and then we have to actually do the work to get rid of those other rows. Now we did something like this in lecture 9. After we called set union, we did some code to remember, hey, where did set union leave off, and let's get rid of everything from there to the end. Same idea. This STL algorithm is going to tell you where it left off. It's basically going to give you an iterator to the first row that you don't want to keep. It's going to give you an iterator just past the last row that got kept. So if there was 4 rows kept, it would give you an iterator pointing to, basically pointing to row 4, 0, 1, 2, 3. It'd be an iterator pointing to this one, get rid of everything from there, inclusive to the end of the 2D vector exclusive. So look at the lecture 9 slides after we called set union. Look at the harder version, not the one that does the wrapper class that does the back inserter. That's the wrong one. Look at the top half of that slide. Okay, so after this, the last two things to do is print where and generate indices. I would say print where is the hardest code to do. I think it was last time we gave this project, I decided I'm going to write this project from scratch. Brand new implementation from the ground up. I'm going to write a really good one that I can give to the staff that we've got staff members who are good, but they did a different project 3. Maybe they're kind of heavy workload this semester. They don't have time to write at SillyQL, but I go on to give them a really good, well-written one. And I just started coding. I'm just like, sit down, burning off code, and I got halfway done with print where, and I realized I'd coded myself into a dead end. And I threw out the code and I started rewriting it, and I coded myself into a dead end. And then I went, you know what? I should be doing what I tell my students to do, which is plan it out before you code it. So I got out my tablet, I drew it out. I'm like, okay, this function is going to do this, then it's going to call this function, and then it'll do that. And then after planning it out, then I was able to write it. So the print where is the most complex function. So I'm going to do that one because at the beginning it's going to be more straightforward than join. Join's going to be the most foreign to you, I think. So we'll do print where, and then we'll come back and do join. Okay. So when we do the print where, first of all, you have to because it's going to be a print where like something is greater than something, like print where price is less than 20,000. So you need to do a four-way split on the type. Then you have to read that type in, call a helper function, give it a field containing that type and the column number that it's on and the column numbers that need to be printed, give it all that stuff. And then the helper function can then start doing like, ooh, wait, well now I've got to do like a three-way split on the less than and greater than and equal to. And then there's going to be other things that come in with indices there. So make sure that when you write up the print where, do the four-way split, call helper, start doing then helper functions beyond there. Now, before we go any further, we're really going to have to talk about indices and generate. So generate is, we need to do generate because generate is actually not that hard to code up. It's the things it's going to do after that. So let's talk about generate before we come back to more print where stuff. So let's talk about why a database has an index. Basically, the indices there are there to speed up future commands. Running a generate index takes time, but it's going to speed up future commands. And so, for example, if I'm a person who sells lots of used cars, I might know that lately prices are really important to people, and I bet I'm going to be doing lots of queries today that involve prices. You know, that people are doing that less than they come in looking for a specific vendor or a specific model. So I might say, hey, let's generate an index on prices that's going to make all my queries later on faster, especially if, you know, there isn't 7 rows to the table, but maybe there's 7 million rows in the table. So I want them to be fast. Now, if I'm going to be doing things like price less than 20,000, hash index isn't going to help me. Hash indexes only speed up equals. They can't do less than or greater than at all. So if I'm going to do less thans, I want to generate a BST index. So BST helps with any comparison. Less than, greater than, it helps with equal. But a BST index is a log n lookup. So it does help with equal. It's not quite as fast as a hash on equal would be, but a BST is nice and versatile. Now, if I get to you know, a time in a month from now where like people are buying lots of Malibus, maybe the next day I come into work, I'm like, okay, today I'm creating a hash index on model because that's what people are asking for. They're asking for specific models a lot. So if I'm going to be doing lots of equals, I'll generate a hash on that column. If I'm going to be doing lots of less than and greater than, and maybe some equals, I'll generate a BST on that column. Now, to simplify your life, a table can only have one index. Now, I could have multiple tables. Each table could have its own index, but a given table can only have one index, can never have more than one. So you could have 2 member variables, one for a hash, one for a BST, but they can't both be full. They can both exist and be empty. That's not wasting too much memory, but only one of them can be full at a time. So if someone generates a new index on a valid column, clear them out, generate a new one. Make sure you clear it out. If you don't, bad things happen. Okay, so we'll need an unordered map for a hash index. We'll need a standard map for the BST index. So then once the generate command is started, it's going to have to remember, right? I do have an index. What type is it? Or do I have an index? I start out with no index. I could have a no index, could have a hash, could have a BST. Sounds like another enumerated type. So I have no index, that's where I start out. I could have a hash later, I could have a BST, but I can only have one of those three types. I need to know what column it's on. Remember column numbers. Don't remember column names. Once you know that a column number is valid, once you know that a column name is valid, you know what column number it is. Remember the column number. So then, to finish the generate, you've got to make sure the index is correct, right? You got to loop over that data and go, hey, if someone generated like a BST on price, I've got to add 25965.00 to the hash and refer them back to this row of the table. Do not make a copy of the row. That would be way too much data. You got to have an easy way to get to the row. Well, what is it? It's part of a 2D vector, right? So what should you store as where to find the price 25965? Think about that. Simple. Think P1. What did we do? Okay. So then you go through all of these. You're like 25965, this one, 7273, that one, etc. You go through every row and do that. Now, what you're going to have to do is you're going to have to go back to the commands you already wrote and make sure that insert, if someone does like an insert and a generate and another insert, that second insert has to participate in the index. So you've got to go through the new rows and make them part of the index. If someone deletes rows after deletion occurs, like if someone deletes everyone where the price is greater than 50,000, and then you say like print where the price is less than 20,000, you got to find the right ones. Now, turns out, I'll give you a hint here, turns out that indices are not your friend when you're deleting rows. They hinder you more than they help you. So don't try to use the index to get rid of the rows. When you've got an index and you're like, oh, I got to redo the whole generate or the whole delete command, not too much. Do the delete like you already did it, and then fix the index. Uh-oh. You're hungry now. We'll get you in a little bit. Oh, great. Now we got to show Cat again. Come here. Let's show everyone you. This is Yuki. She's a Maine Coon. She's completely deaf, and she is very, very food motivated. And it is her dinner time, but she'll get fed after video's done. Okay, so when you do the delete, so do the delete normally, and then go back and fix the index. It turns out fixing the index is hard. Think about something that's easier, and think about this. If you try to fix an index, at best, it's going to be O of the old number of rows. Well, now that you've deleted, there's probably less rows. We want O of new number of rows. So think about an easy way to do that. It's easy. Don't make it too hard. Okay, so now we've got an index generated. Now let's go back to talking about print again. Now print all is not going to change. Whether there's an index or not, I don't care. I'm not even going to look at it. Print all remains the same. And this is a place where maybe even more member functions would help. Like, hey, I've got a print all member function. I've got a print where member function. All right. So in the print where, what you want to do is you want to start by checking, does an index exist? Whether it's on the right column, and whether the index helps me. How can an index exist in this table on the right column and not help me? If I say print where greater than and it's a hash, you do it as if there was no index. So we're going to need like a print where when there's no index, a print where when there is a hash that helps us, a print where when there's a BST that helps us, and maybe even that one will go three ways for the less than, greater than, equal to. You might do three helpers there, you might not. It's not too bad either way. So you want to say in the print where, if there's a hash and it's on the right column and I'm doing an equal, new code. Else, if it's a BST and it's on the right column, new code. Else, code that doesn't worry about an index. So if you want to do the print where without an index, that's fine. Do the print where without an index. Put it in its own function. You're going to call it when there's either no index or the index is on the wrong column or it just doesn't help you. So this is a place where code doesn't get thrown away, it just gets moved around. All right, so when we do a print where with a hash, basically if someone said like print where model equals Malibu, I'd be like, hey hash, does Malibu exist at all, right? If someone says like print where model equals navigator, right? I go, are there any navigators? Nope, we're done here. Fast. But if there are navigators, maybe I'll loop over the 10 navigators instead of the 10,000 rows in the whole table. Really speeds us up. Okay, so we do that for the hash. For the BST, we're going to do it different if it's less than, greater than, or equal to. The equal to is going to look a lot like the hash version. Hey, BST, do you have a navigator? Oh, you do? Okay, let's print those. Let's print all the navigators. Oh, you don't? Okay, I'm done. No rows to print. Okay, then for the less than and greater than, you're going to want to do it differently. Because the BST has, you could loop through the whole BST, but that would be a waste of time because the BST has some member functions that can find you this place or that place. So you could print from like this position to the end when it's greater than, or you could print from the beginning to this point if it's less than. So the BST, the hash table has some member functions that the BST standard map has member functions that standard hash does not, to find places that maybe don't even exist, right? I could say print where model less than, I'm trying to think of something that doesn't exist that is in this range. I should have thought of more cars before I got here. I don't know cars that well. Encore. Print where model is less than Encore, right? You can't do a find on it because it doesn't exist. There's member functions that'll help with that. So look at the standard map and look at its member functions for looking stuff up. There's a find and there's two others that'll really help you there. Okay, so this brings us to join. Now, first thing about join is join does not create any new rows. It doesn't create any new tables. It just does the result of the join and prints a bunch of stuff. The other thing about join is that it is called with two tables. And you're like, wait a minute, how do you do member functions with two tables? Well, you could say, hey, assuming they both exist, table 1 member function, here's table 2. Oh, better definitely pass it table 2 by reference, of course. Okay. All right, now I got to rearrange things on my desktop here, and then I'm going to start sharing differently so that we can go through a join in a minute. Okay, so the basic idea of join is that we're going to match up things in the first table with things in the second table. Okay, so I think I got this ranged well. There we go. Wait, all right, let's do this. And I got, no, that's just worse. Okay. Okay, let me go back and see if I can reduce the size of this a little bit. No, that doesn't help any. It's still in the same place. Okay, this is not going to be perfect, but it should be good enough. Let me move over just a little bit. We'll crowd it a little bit. There we go. Okay, so we can see most of it. And I've got sample output below, and the input and output to produce this is in the starter file. So there's like join input and join output. It's all in there. All right, so the idea of join is, what I want to do is I want to do the same effect that would basically happen If I was to write the naive implementation of join, it would basically say, hey, let's loop over all the rows in table 1, cars marketplace. So that's my command here. So it says I've got, oh, I forgot to intro this better. Okay, so I've got a new table over here called prof cars. In the prof cars, I have 3 columns: name, vendor, and color. And some of these are true, some of them are made up. So anyway, so I've got these, and I said join cars marketplace, table 1, and prof cars, table 2. So right, we got table 1, table 2, where capital vendor, notice capital vendor over here in table 1 is equal to lowercase vendor, lowercase vendor in table 2. So what we have to do is print the results. The naive approach would be, and this is too slow, but the naive approach would be loop over every row in table 1 and then loop over every row in table 2 and say, hey, I've got a Corvette in table 1, table 2, row 0, are you a Corvette? No. Row 1, are you a Corvette? No. Row 2, are you a Corvette? No. Row 3, are you a Corvette? No. So row 0, oh wait, sorry, I did this on vendor. So I say, hey, I've got a Chevrolet. Row 0, are you a Chevrolet? No. Row 1, are you a Chevrolet? Yes. Okay, so that matched. Row 2, are you a Chevrolet? No. Row 3, are you a Chevrolet? No. Okay, let's go back to row 1. Row 1, Chevrolet. Go back to table 2. Are you a Chevrolet? No, yes, no, no. So you have to, that would be the naive approach. That would give you right output. It would be way too slow. So we have to produce output as if we had done that. This is a place where if you write the naive approach, you're going to have to throw it away because it's going to be too slow. So what you need is you need an index to speed this up. So if the index that you need doesn't exist, make a temporary one in like a local variable inside the join member function. Make a temporary hash table to make this thing faster. Now, as I said, the order has to be the same order as if I had gone through every row of table 1 and gone through every row of table 2. So then think about which table, and the example I just did, which table would it be helpful to have an index on? Obviously, it would have to be on the vendor column, uppercase or lowercase. It would have to be on the right column, but which table would it help me to have a hash table on? One of them, yes, one of them, no. So think about that. Now, let's run through our example here, and I've got this prepared. So like I said, so we run through, when I get down to Cars Marketplace row 0, 1, 2, 3, 4. When I get to row 4, it gets a little more interesting. I go, hey, I've got a Ford. Table 2, do you have a Ford here? Yes, that matches. No, yes, this one matches. I got 2 matches for this one. So if we look at the output, there should be 9 rows of output. 1 row here, 2, 3, 4, 5, 6, 7, 8, 9. And I know this is a little bit, I'm a little bit off the screen there. I don't have an easy way to make this better. Let's just move it over a little bit. We can overlap the prices there because really we care about the models. Okay, yep. So we can say, hey, this produces 1 row, 1 row, 1 row. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9 rows of output. And here's what it should produce. So I said join Cars Marketplace and Prof Cars. Now really the join command should be all one line. I put it here on 2 lines just to make it more readable. But in the input it does have to be all on 1 line. But a well-written program, it really shouldn't matter. A well-written program should just be greater than everything here, and it should work just fine actually. Okay, so the output for this, and I said and print. Oh, and we should understand this. It says and print 3 things. Print capital model from table 1, print lowercase name from column 2, and print lowercase color from column 2, which is name up here and color up here. So I'm going to print the model from table 1, and then I'm going to print, whoops, and then I'm going to print the name and the color from table 2. And you don't have to put them in this order. You could say, and print 3, name 2, model 1, color 2. The columns would be in a different order, but otherwise you'd have the same rows. Okay, so here's the output of that. First things is the names of the columns, and to make this project easier, we didn't make you figure out like how wide each column was and make it line up pretty. Too much work. So we print the column headers, and then we print all of the matching rows. There's a Corvette up here that matches because it's a Chevrolet. We're not printing vendor. We matched on vendor, but we're printing the model. So we say that, hey, there's a Corvette here in table 1 that matches Paoletti's data in table 2. It matched the Chevrolet part, and it prints the color blue. And then it goes through, and there's the output. So like I said, this one, and then at the end, we get a summary line of what did we do. And we haven't talked about it. I didn't realize until right now. I haven't even talked about quiet mode. So if quiet mode was on, you would basically see this. You would get the summary. I know you wouldn't get the rows. I'm pretty sure you don't even get the column names. I can't remember. Make sure of that one. But you wouldn't get the rows. You'd only get the summary line. So that's what quiet mode does. Is basically it shrinks the output so that it doesn't fill up the hard drive on the autograder. So that's why quiet mode exists. So quiet mode is really going to come into play in print all, print where, and join is the ones that really have to worry about quiet mode. But you got to print the summary. It printed 9 rows. Yep, we printed 9 rows there. The headers, the column headers, does not count as a row. It's just the names of the headers. There's 9 actual rows of data there. Okay, so like I said, if we look at the spec again, over in the starter files, so we've got the tarball, error messages, there's only 2 of them, field.h, field.cpp. Like I said, don't look at these too close. Field.h has the, like the first 20 lines is the important stuff. Makefile gave you a project identifier. It's in the spec also, but we gave it to you here. We got the checkpoint 1, 2, and 3. The checkpoints exist as test cases on the autograder. They're sort of ways to gauge your progress and also extra small inputs. Join input and output comes from the one we just did, and spec input and output come from the one that's in like the spec example. And then also, like I said, make sure you look at the project video. Obviously, wait a minute, why am I even saying that? I'll remind you to watch the video that you just watched at the end of the video you just watched. Okay, anyway, that's the stuff you've got. The project spec is big but very useful. This is a very useful, very cool project. So enjoy yourself with the project. Good luck on it. We'll be there for you in office hours.